Hello. It is our pleasure to have Dr. Ding here to give a talk about non-reciprocal light harvesting nano antenna made by nature. Doctor, let me introduce briefly about Dr. Ding. After earning his PhD from National Tsinghua University, he has been to many places like Cambridge University and South California University. And he has plenty of experience both in, I think, all in academic area, right? He also authored many books in a diverse area. So let's welcome Dr. Lin and let's applause.
It's my pleasure to be here to present some of my research. Today I'm going to talk about photosynthesis. It is made by nature, and because photosynthesis receive energy from the sun, the solar energy. So it is light harvesting nano antenna. And to make an antenna receive the energy, it has to be non-reciprocal. And I am studying its property and in the hope that we can make some artificial light harvester. Today's talk will, first I will outline how did I get involved in this project and some of the background knowledge in photosynthesis, and I will analyze something I found in the nature synthetic antenna, and then I will talk about some of the application. It happens in 1995 when I just received my PhD and start my postdoctoral work. I found two articles. The first article is about quantum computing by Sis Royce. The article appears in Scientific American. The other paper I found is about photosynthesis. It says they have made X-ray image to atomic resolution. They found this molecule. Did you notice this molecule is so symmetric? I find the symmetry is astonishing because in physics, symmetry is an important property. So I started to study these two projects. And the first paper I published in this and has become important. It has been 30 years since that. And now this field was called quantum information theory, but now it is called quantum technology. Quantum technology actually means quantum engineering. This means we are trying to make quantum computer possible. But the question is, how do you make quantum computer? So some of the people working on it, this is Divicino was a leader in IBM Group in the United States, but he now moved to Germany in Aachen, and they study. Their project now is called light-matter interaction. So light-matter interaction is what I'm studying here. This molecule I'm studying receives some light and it's interacting with the material. So this is actually light-matter interaction. So this relates these two fields together. This provides the motivation for us to study the photosynthesis. Now I will tell you something about photosynthesis. This is high school textbook issue. You know, the Earth. In the Earth there are plants and animals, but plants will come earlier than animal because only plants can receive solar energy and convert it into energy. This is also high school biology. If you take those leaves and under microscope, you will see something like this. It's called chloroplast. If you magnify this picture further, you will see the chloroplast. Chloroplast is the power plant of plants. It's similar to mitochondria in animal. You can further magnify it, but this has become quite complicated. Something sitting between two membranes. This is called photosystem. There are actually two kinds of photosystem. They call photosystem 1 and photosystem 2. But this is very complicated. Physics do not want to study complicated systems, so we choose to study bacteria. Bacteria, there are several kinds of bacteria, but they are all very simple. Whatever you are, plants or bacteria, you going down to the molecular level, you will see what is called chlorophyll. This molecule is very special. It has a head and a tail. In particular, this head has a special name in chemistry. There is a metal sitting at the center of this molecule. You will find later that this molecule again. But how will nature assemble this molecule? You can choose to assemble it into bundle or into such as a ball. But nature actually assembles it into a ring. I will show you. It's this molecule has 8 modules. You can count. Here is 1, 2, 3, 4, 5, 6, 7, 8. It's formed a ring. And each unit is actually consists of 2 chlorophyll and 1 carotenoid. This is something very interesting because 2 plus 1 is make the bundle asymmetric. This is one of the important trick nature is playing to make. This is light harvester. This is side view. One of the trick nature is playing to make the harvester a non-reciprocal. We will mention this later. Chemists use spectroscopy to study such photon after photon transfer. They study it, but I don't understand it. The basic physics is this way. When the light comes in, the light will jump from one module to another. Chemistry measure is about 500 femtosecond. And you see, there are 2 kinds of molecule here. This guy is smaller. Its center contains nothing. This guy is larger. This one is larger, and its center contains something. This something is called reaction center. All magic happens in the reaction center. There are 2. This is called light harvester 2, light harvester 2, light harvester 2, and this is called light harvester 1. When the solar energy comes in, they collect the energy and transfer it to light harvester 1, and some chemical reaction happens here, and then the plants convert it into various chemical compounds. What physics can study is this process from the light comes in to the transfer to before the reaction center. This is called first stage of light harvesting process. I will mention here, there are actually 3 in the history. There are not many physics studying photosynthesis. The earliest one is someone called Duison, but he used thermodynamics to study photosynthesis. His thermodynamics physics actually has nothing related to photosynthesis. It only contains particle. And later many people, this is standard theory, they call it exciton theory. They assume the photon is some quantum photon, and it will jump from here to here. But the problem with this theory is contains no structure of the photosynthetic system. And I'm the third one. I use antenna theory to study the energy transfer. But you will find my model contains the structural information. This is my model. I superpose the molecule here. The molecule looks like this. The molecule is here. You see, here is a notch. Here is the center. This is called reaction center. Did you notice here is one thing. Did you notice here? This is reaction center, and this is actually called special pair. There are two lines goes to the reaction center, and at the reaction center here is a metal here. I mentioned earlier. I mentioned here is a metal here. Here is again. So the nature actually made the molecule has several levels. My interpretation means fractal. I will mention it later. But you see, this molecule, for a physics, when I saw it, I immediately consider it as an antenna. It's a loop antenna. It's about 10 nanometer. It's about 10 nanometer. There's one thing. Did you notice? The circle I draw is completely circular, but the nature molecule is actually a little flat. It's a little flat. This is one trick nature is playing. They make it non-circular so that it can be non-reciprocal. I will show you the theory later. So I submitted this modeling, but my paper was rejected. This is the referee report. He said first, the photosynthesis, the chlorophyll is where did he say? He said the chlorophyll is an isolator. Isolator, actually, in physics we call it dielectric. He said the antenna must be made of conductor. He said must be made of metal. So his report raised two questions. Is this molecule conductor or dielectric? This is a question. And could it be modeled as antenna? When I faced the report, I immediately go back to read my textbook. I'm a physicist, so we are educated using Jackson's book. I find the answer of whether it's conductor or dielectric is stated in Jackson's book. Jackson stated dielectric or conductor, the conductivity is a bulk property. It's an average of several hundred molecules. So if you are in the molecular level, only facing with only a few atoms, then you can't talk about conductivity. There's nothing as conductor or dielectric. This is the first question. So the question 2 is easier. But question 1, could it be modeled as an antenna? I go back to read textbook. The standard textbook for antenna is, this is a cross antenna theory, and this is more modern one. But they didn't have any, they didn't say any necessary or sufficient condition for being an antenna. So I finally concluded, this is my proposition. Proposition means a statement that can be stated either true or false. I said everything mediate between your system and the electrical wave field is an antenna. You can verify whether my statement is correct or not. It is interesting that I searched for the literature. The light harvester has been called antenna since about 1970, but nobody ever considered it as an antenna. So I'm the first person to consider it as an antenna. But the question is, could it really be modeled as an antenna? I conducted literature search. I find the first thing, this is something I made after I can master these 2 questions. I find many literature contains mistake, but let's forget this one. I find in the literature there are people studying dielectric resonance